So now I will start with my presentation, but first I want to do a quick recap. Where are we now? Hannes just explained the basic concepts. What is GenAI? What does it consist of? And what are some important trade-offs that we need to make? Now I will take a specific use case and dive a little bit deeper in the use case and see how we can leverage metadata and how we can integrate it in our data platform. So this is the flow that we have in this presentation. So first, we will need to understand the use case. Then we need to find out, does it work? Are there some challenges? And there will be some challenges, so we need to improve it. We will try to make it as good as possible. And we will partly do it by leveraging metadata. And then in the end, we will onboard the use case on our data platform. So the use case that we will use in this presentation will be a chatbot for internal use in a company. So why would we have such a use case? Well, to increase productivity. It can also increase employee satisfaction, knowledge management, and so on. So it's a reasonable use case to pursue. And then what architecture will we use? So Hannes already mentioned it. We will use a RAG-based architecture. So you, of course, already know it, but I will still recapitulate it. I don't want to say that you didn't explain it very well, just because it's an important part during this presentation, so you really need to understand this part if you want to follow along. So let's start. Let's just go through it. A user asks a question, a query. Then we have some company documents, and then what will happen, we will do a similarity search. So we will look and compare the query of the user against all the company documents and calculate the similarity. The documents with the highest similarity are retrieved. This is what we call the retrieved documents. And then these documents are sent to our foundational model together with the query, and then the foundational model proposes an answer. So what did we do at Dataminded? Some months ago, we had a hackathon, and there we actually built a chatbot for internal use. And we made a Sensei Seeker. And Sensei Seeker is a chatbot based on our check-in messages. And what are our check-in messages? We use Slack a lot for communication. And every morning, every employee of the company here of Dataminded just writes what he or she will going to do that day. And then that's the daily check-in message that we all are doing. And then we made during the hackathon the Sensei Seeker, which is based on these Slack check-in messages. So you can ask a question about all the check-in messages and the employees. The foundational model is Gemini. And why do I mention it here? Well, I will use this example, an internal chatbot, to illustrate some concepts and examples in the further part of the presentation. Let's walk through how it works, the Sensei Seeker. So first, somebody can ask a question, for example, on which topics did Johnny work? Then what will happen? The query will be compared against all available check-in messages. I just showed here some examples. We have a check-in message, we have the query, we calculate similarity, and then only the most similar queries are retrieved. And the most similar queries are retrieved and also sent to our foundational model together with the query. And then the foundational model, here Gemini, will propose the answer, and it explains on what Johnny did work based on our check-in messages, which is really cool, actually. And the pointer is working. So now we can be very happy because we have a chatbot, it works. And you might think now everything works very well, very good. Actually, it's not the case. It's also related to the question that you were asking before. Yeah, how do we measure it? Well, a part of the answer is we need to measure continuously. And that is also what we will see. So I asked one question, it works. But actually, if we start to ask more and more questions, we will figure out it doesn't work always. Sometimes it just says, I cannot answer the question. I asked the chatbot, who is Frederic, that's me. And it just simply says, I cannot answer the question based on the retrieved check-in messages. That's not what we want. So what's the cause of this? Well, first of all, it needs to retrieve the relevant check-in messages, which was probably not the case here. And also, our foundational model needs to understand the messages. It needs to know if there are check-in messages. Here are the employees of the company Dataminded that write these messages. It needs to be aware of what are these check-in messages. And if the model doesn't know it, it just says, yeah, I don't know it, I can't answer your question. So what do we need to do? Our first challenge, we need to improve the accuracy. The responses need to be better. A second challenge that we figure out is, what if we ask this question? For example, which of our colleagues has had a medical problem and what was the problem? Which is kind of a personal question. And we don't want that our chatbot answers such a personal question. So here it was an answer. I put a box on the answer because it's personal. So that's not what we want. And what's the root cause here? Well, the cause is our chatbot is simply using all our check-in messages. It doesn't look, oh, this is an inappropriate message, I won't use it. Or this is a message that contains very personal information, so I don't use it. No. It just retrieves all check-in messages, sends it to the foundational model proposes an answer, that's it. That's not what we want. We want to have a chatbot that's safe. So one of our goals is to improve safety. And then a third challenge is efficiency. So here, for example, I ask, who is Frederic? The same question as before. But it might be that the chatbot takes just a long time, and that's obviously not what we want. If you have to wait for multiple seconds, it's not going to be very productive or satisfying for the employees. And what are the root causes here? Well, we need to do a similarity search against all the check-in messages, and the foundational model also takes some time, the interference time. So we need to improve the efficiency. Here I summarize our challenges. So we had accuracy, safety, efficiency. So these are just 3 challenges that I highlight here. But I also want to raise awareness. These are not all the challenges. There are, of course, multiple more. Like I also place here on the slide, compliance, transparency, security, and so on. So I want to stress this. Try to figure out all the challenges, try to figure out all these things, and make sure that you propose a solution for a challenge that you might identify. So what's the key message or the learning that I want to give away in this first part is there are multiple challenges. So we can quickly set up a chatbot. You can ask it a question. You might think, okay, it works nice, but try to ask more questions. Try to search for the edge cases and write the challenges down. Get a clear overview, a transparent overview of the challenges as a first step. And then a second step, try to find solutions to solve the challenges. And that's what we will do in the next part of the presentation. We will try to improve the use case. And here on this slide, I identify 2 buttons that we can tune to improve our chatbot. So first, the yellow part is the foundational model, which we can improve, of course. And then a second part is about the document retrieval. So our company documents, we need to retrieve them. We can also improve that part. So first, the foundational model. There are multiple versions, multiple times. There are always new and better ones released. And basically, if we improve that foundational model, we get a better understanding of the world. So the foundational model is trained on all publicly available data, so it better understands all publicly available data. And I wanted to illustrate this here with an example. I asked a question about a financial statement, and then I provided a retrieved document, which is a financial statement. I asked this question to 3.5 and GPT-4o, and you can see that the newer version gives the correct answer, whereas 3.5 gives a wrong answer. So you see, improving the model version improves understanding of the world, so the model better understands financial statements and can give better accuracy, which is exactly what we want. However, there are some limitations. What if I ask a question that is very specific to my company? The model can be as good as possible. It doesn't know about specific company data. So here, for example, 3.5 and 4.0 gave a wrong answer. So 3.5 just says, I don't have the context, I don't understand it. 4.0 says, or start to invent some things and claims that he knows what's going on, but actually the model doesn't know what is this update about or what is this project. So the basic foundational model isn't aware of the specific company data. So these are some limitations on improving a foundational model. And what I want to stress is the understanding of the world of all the data that's publicly available and create a contrast between all the company data and the understanding of the company data, because these are two different things. Improving the foundational model helps improve understanding of the world. Now, how can we improve understanding of our company documents? Well, if we are going to look to the green box. So why do we want to look to improve understanding of our company data? Then what can we do? Well, we can try to retrieve the most relevant documents. And then if we retrieve these documents, we can try to make them as understandable as possible, really try to explain these documents to the foundational model. How can we do this? Well, we can look to the core data quality. Well, I won't go into detail here because I'm sure that you have seen tons of LinkedIn posts that state that data quality is very important. And I completely agree with it. It's very important, but I expect that you all know it already. So I won't go into detail in this one. I will talk about metadata, which is also a very important part that we leverage to improve. So in this section, what I want to say here, we have two buttons to tune. First one, foundational model. We can improve understanding of the world. And second one, our company documents. We have to retrieve them and we can try to make them as understandable as possible. Now let's see how we can do this by leveraging metadata. And before diving into it, I want to explain metadata. Well, it are basically the answers to the questions that you see here on the slide. So the question why, what, when, and so on. So every piece of information in our company has metadata, has a specific context. And what can we do? Well, we can go through all the company documents. We can derive metadata for every piece of information that we have in our company. Then we can attach this metadata to all the documents and then store them again. So that's creating or deriving metadata. Now, how can this help us? I made two categories. First of all, we can improve document retrieval with this metadata, which is this part. And then secondly, we can improve the understandability of our documents. So let's dive into the first one. Here, I will show it with an example. Without metadata, I asked the Sensei seeker, what clients did Chris work for? And then it gave me an answer, but the answer was not correct. And you can directly see why it was not correct. Well, it mentions Johnny, what Johnny was doing. It also mentions what Cedric was doing, what Robert was doing, but actually I'm not interested in that. I was interested in what Chris was doing. And so the response is wrong. So then we fine-tuned the Sensei seeker a bit. And after fine-tuning and using metadata, we got the correct answer. And now I will explain you what we did. Well, we have here the question, what clients did Chris work for? And then we introduced a new step, so to derive the metadata tag. Here we said one of our metadata tags will be the author of the check-in message. We derived it from the check-in message, and here we figured out it was Chris. We also have tagged all our company documents, and we have a stack of check-in messages from Chris. And then we can simply compare, do a similarity calculation between the query and the company documents, or our check-in messages, with the same metadata tag. If we do this, then we retrieve much more relevant check-in messages. We send them to the foundational model, and we get a much better answer. Then a second part, so this was about retrieving more relevant information. Second part, making this retrieved information more understandable by the foundational model. Here I also start with an example. I asked a chatbot, what are the benefits for our employees? So imagine we have a chatbot at our company and we want to know what are the benefits for our employees. We are going to do a comparison between the company documents and our query. And then you might retrieve something like this. We might retrieve, for example, 2 documents. And the one states the benefits include access to gym facilities and mental health support. And the second one states benefits include 24/7 support and access to the beta features. And we also see the metadata tags. And for us, it's quite clear, okay, the first message or the first document is about employees. It's employee satisfaction and the wellness program. And the second document is about the product that the company is developing and just lists the features and the benefits for users of the product that the company is developing. Well, if we send this retrieved information to a chatbot, and this is something that I tried, I made a GPT, provided the instructions, which is the retrieved documents. I asked the same question, and then I got the correct answer because the GPT knows, oh, I only need to use the information from the first document because the second document is not about employees, it's about the product. So this is really using the metadata to make our documents more understandable for the foundational model. Then I tried exactly the same, but just without the metadata tags. And if you do this, then you see that you get the wrong answer. Now it specifies the benefits include all the 4 items, which is wrong because the foundational model is missing the context of our company documents. So what I want to show with this, we can really leverage metadata and pass it on to the foundational model to improve its understanding. And now let's go back to the challenges that I have shown in the beginning of the presentation. We found out that the retrieved information wasn't that great here. Well, we include metadata tags, and then we see, now the question is properly answered. And it could even come up with my full name and tell some things about me. Then the second one, if we add a metadata tag to all check-in messages, whether it contains personal information or not, then we can retrieve check-in messages. And if we see one of the check-in messages had a personal information tag, then we can mark it and we can say, okay, this message is not appropriate. I won't share any details. And then the efficiency part, which is about the time and the cost, has 2 aspects, the similarity calculation and the foundational model. Well, the first part, similarity calculation, we can try to improve by only selecting the right documents to compare to, so not compare against all the company documents, but just a subset. And secondly, if we only retrieve relevant information, we have to retrieve less. We don't have to retrieve all documents anymore. And therefore, we have less input tokens, and you can also try to gain or to reduce the cost of the foundational model. So we have a chatbot that we could improve, which is really nice. Here is a short overview. So we have accuracy, safety, efficiency that we try to improve with the metadata. And then I also have a note here on the slide, with which I want to tell this metadata that I have shown, the examples were about text. So it was all sentences and text. But actually, the power of metadata becomes even more important when working with images, tables, and graphs, because this is even more important, even more difficult for the foundational model to understand. Therefore, if we can derive tags for images, tables, and graphs, then we can also make these objects much more understandable for the foundational model. And then, if you don't believe me, I did also some research on the web, and there are some famous AI people that also state that metadata is really important, or also Intel and BCG wrote articles that it's really important to leverage metadata and with this to improve the foundational, the GenAI application. So a quick recap. I showed you ways to improve GenAI application. Well, first of all, we could improve the foundational model by just taking a neural model, improving the world's understanding. Then a second one, we can improve document retrieval by leveraging metadata. And then a third one is leveraging metadata to make the retrieved documents more understandable for the foundational model. So now the last part, which is about the use case that we now improved. We think, okay, now it's quite good. We want to onboard it. This image I already showed you. It's the flow of the data in our GenAI application. I structured it in a weird way, but it's because I want to show you some steps in between. So what I showed you previously here, this is actually a high-level image. What actually required to realize it are a lot of data engineering steps. We need to onboard a lot of data. We need to integrate it with our data platform. We need to do cleaning, tokenization, chunking, tagging, and so on. And then we need to store all the embeddings in a vector database. So it are actually a lot of steps. I will briefly go through them. And the first one is the onboarding of unstructured data. So what do I mean with unstructured data? It's data that's not in tables. So it can be in documents, mails, images, videos, or everything what we can find on a website. And actually, there are predictions of estimates on the internet that state that 80% of all data available is unstructured data. So it's a lot of data. And now we also know that GenAI applications actually use for the major part unstructured data. So if we want to build a GenAI application, then we need to onboard a lot of unstructured data on our data platform, which we didn't do in the past. Maybe there were some use cases, but most data platforms or data programs didn't onboard that much unstructured information. So this is already one big aspect that is different with these GenAI use cases. We have a lot of unstructured data. We need to have integrations for these new data sources, and they also require cleaning. Then a second aspect is the chunking and tagging. And I hope, yes, slide is here. So with chunking and tagging, chunking is really taking the documents, cutting them in pieces of coherent meaningfulness. And then we can derive for every chunk of information, we can derive the metadata, because we have seen with metadata, we can improve our GenAI application. Well, you might think, okay, how do we derive all this metadata text? If a human needs to read all the documents, it will take some time. Well, luckily for us, there are now already applications which are also based on GenAI that can do this for us. So, for example, here we have Daisy or 𝐒𝐞𝐧𝐀 that can do this chunking and also automatically derive metadata text and automatically attaches to the unstructured documents. So that's a way to create or derive the metadata text. Then we store them in the vector database, and then we have the complete flow. Now, if we have a look to this, then I made two parts of it. So first, we have the GenAI application, the product itself, the data product. And then secondly, we have a GenAI data pipeline. And what I want to stress here is when we want to make a GenAI application, we need to be aware that we also need a totally different kind of data pipeline on our platform, which is this part. And now if we compare it to the data engineering lifecycle, is what I show here below. It's written by Juarez in the book of Fundamentals of Data Engineering. He proposes this data engineering lifecycle. Well, we onboard structured data, we ingest it, transform it, we create serving data, and then based on the serving data, we can make some data products. That was proposed in the book, the Data Engineering Fundamentals. Now, if we compare it, we actually see that building a GenAI data product has quite some similarities, but it's not the same. We have another data product in the mix, a GenAI data product. We also have input, but it's not structured data this time. It's unstructured data and tons of unstructured data. We will need to have an ingestion flow. we have a lot of new transformation steps, and we need to store the data, not in a regular database, but in a vector database. And then we can use this data in the vector database, the embeddings, for our GenAI application. And then as a final step, what is also very important, even more data engineering steps, if we want to go to production, we need to have orchestration. We need to know when to run the pipelines, when to run which tests. Do we run it every day? Do we run it every 5 minutes? Do we run it when there is an update? We also need to build and include monitoring. We also need to write documentation. We also need to provide alerting. What do we need to do when there is something that fails? Who do we need to notify? And so on. So these are, again, a lot of data engineering steps. And what do I want to stress with this? Well, it's not simply the orange box if you want to make or build a GenAI data product, but you also need to take into account the green box and everything that comes around. If we do this all properly, then we can be really happy and have our chatbot. And then we are also at the final slide. And here I will briefly go through the story. So we started by defining an internal chatbot. In our case, the Sensei Seeker, based on our check-in messages. We identified several challenges. Then we have seen that we can leverage metadata to improve our chatbot. We can increase the performance of the foundational model. We can improve document retrieval. We can make our documents much more understandable. And then finally, I also raised awareness about this data pipeline, because we need to onboard a new kind of data pipeline on our data platform, which requires new kind of data, new kinds of transformation steps. But luckily, there are already tools available that can help us with this metadata tagging and labeling. But still, it's very important, this data pipeline. And that was all for my presentation. So thank you for your attention. If there are any questions. Yes?
Can you have like too much metadata? For example, to know which kind of questions that will be asked in the future. So we have to put that pipeline in metadata, and can you have like too much metadata?
Yes, I can imagine that you can have too much, because you can keep creating metadata, and that's a trade-off that you need to make, and that's also all about monitoring. So start simple, start with these fundamental questions, give the answer to that, attach it to your data, and keep monitoring continuously, keep monitoring everything, and keep including metadata if you see that performance is still including. It really depends from use case to use case. I can say this is the quantity of metadata that you need. Depends on use case from use case to use case. Yes. Yeah.
So I understood now next year moving to adding additional semantic level on top of that, and do you have some experiment with graph database paintings, knowledge graph paintings?
Yeah. So the question.
Some context, different good results with people reports, but it's not fulfilling.
Yeah. The question is about, did I use graph databases or knowledge database to improve this performance? Yes. And the answer is simply no. I didn't experiment with graph databases or not, knowledge databases. So, yes?
In what way do you typically integrate this metadata? For example, we try different things. So we do a hybrid search where we do an exact match on metadata together with a vector search on the actual content. We also play some metadata in the content itself. But it's difficult to figure out what works best, and then when we want, actually you probably want some mix of different vector searches with different embeddings. It's all kind of.
Yes, that's a funny question. I like the question because I actually originally had several slides, because now I showed you one way to do it, and which is actually doing the exact match of the metadata tags. But I had originally multiple ones, and that's indeed, I also cannot say this is the best one, which is also something to figure out. There are multiple ways. So here you can have the metadata, which in the one that I proposed in the slide was to do the exact matching. You can also include metadata in the embeddings itself. You can also do similarity searches on the query against company documents, and do also a similarity search against metadata and all the other metadata tags. So there are multiple ways you can combine them and see which one fits the best. That's one thing with these GenAI use cases. There are a lot of questions, and it's not possible to say this one is the best for every use case. In my opinion, it's about building monitoring pipelines, have a really good monitoring, and then really keep on experimenting, keep on making small changes and figuring out what leads to an improvement and what does not, and try to improve steadily. Yes?
Is metadata static, or do you modify that dynamically throughout time and you get data with or new documents you really need to retag everything?
Yeah, that's also a very good question. And here, this depends on also on the use case again. And this is really lagging. Yeah, here, this is what I want to show. It's about the orchestration part. When do we want to run this tagging again? And this is really use case dependent. If we have very static use cases that don't need to answer really recent information, then it's fine to update every day or every week, depending on the use case. It's similar to the data pipelines that we have now in Airflow. Every data pipeline, or a lot of data pipelines have different frequencies to run. And it also depends on the use case. Not all data pipelines that we have now on our data platform run with the exact same frequency. It depends on the use case. And it's exactly the same here. We will have different GenAI data products for different users with different use cases. And some use cases require really near real-time information, and then you probably need to update every time that you detect an update in your buckets, for example. But when it's not that critical, you can say, to reduce the cost, I just want to run it once a week, for example. So I can't answer it because it depends on the use case, but I can say you have to look to this component. You need to have a good orchestrator that can really very well orchestrate these pipelines, that you can see, okay, this pipeline runs with this frequency, and so you can be updated and notified when something runs, and you have a clear overview. That's, I think, the most important. And then you can always fine-tune it as you, in the way you want. If there are no more questions, then I propose to take a break. You can go and grab some beers below, or maybe there are some pizzas left. Or if you're interested in the big table that Hannes has shown, then you can go to Hannes. Thank you.
Let's meet here around 15 minutes, so around 40 minutes, like at